We're starting here with question 6 with the topic chemical bonding. These are the short answer questions from the 2015 Regents exams. Okay, so once again, we're given a table here, and we're told above the table that this is a sample of seawater, and we're given the concentration of some ions. So here are the ions, here are the concentrations in molarity, and let's go to the questions. All right, so 6 and 7, I determine have to do with chemical bonding. Anything that's crossed out is in a different video for a different topic. So with number 6, you're asked to write a chemical formula of one compound formed with, by the combination of, these are potassium ions, with one of these ions as water completely evaporates. Okay, well, potassium as a metal ion is going to want to bond with something that has a negative charge, and there are two possibilities based on the table, and one is chloride, and the other one would be sulfate. Now, in the case of potassium chloride, since potassium is +1, chloride -1, you could just put the answer as KCl. Or you could have put potassium sulfate, but here you had to be careful because potassium is +1, sulfate's -2, and you, as I say in my class, you have to crisscross the numbers. You need 2 potassiums for every 1 sulfate. So KCl and K2SO4 are both perfectly fine answers, but KCl, let's face it, is easier. Alright, let's move on to number 7. You're asked to compare the radius of the magnesium 2+ ion in seawater to the radius of a magnesium atom. Well, first thing let me do is erase this, and I'm going to give you something to help you remember this, to keep it kind of straight in your brain here. Somebody else came up with this, and I always use it with my students, and it's called MELPS helps. Now, MELPS, what does that stand for? That stands for metals, electrons, lose. Let me get rid of the helps here, it's kind of in the way. And then the metal, of course, becomes a positive ion, and also it's smaller in size compared to what it was as an atom. So MELPS is a made-up word, but it says metals, electrons lose, positive charge, and smaller. So the radius of a magnesium 2+ ion is smaller than the radius of magnesium atom. Let's move on. Okay, again we have a table here and information, and in question 8 it says identify the 2 types of bonds in the solute. Well, the solute is what's doing the dissolving, and right here up at the top I'm told that ammonium chloride was dissolved in water. Now, if you forgot the formula for ammonium chloride, if you take a look at the data table, let's see, you're told the solute right here is NH4Cl. So 2 types of bonds. Well, there are only 3 possibilities, of which you're looking for 2. Okay, I think covalent is pretty easy to see, because covalent bonding is non-metal bonding. That leaves you with one of the 2. So the other possibilities are ionic or metallic. Well, ionic usually is metal-non-metal, and there's this exception, and that exception is this ammonium ion. This cluster of atoms, this polyatomic ion, behaves as if it is a metal because the electron gets transferred to the non-metal, even though, again, it's not a metal. So that's your answer. It's ionic and covalent. Metallic is just plain old for metal atoms bonding with other metal atoms. So this is not a choice. So your answer for 8 was ionic and covalent. Alright, let's go down to number 9 here to wrap up bonding. Alright, so for this question it says, explain in terms of molecular polarity. This is the third time we're seeing basically the same question, and you're asked why these two molecules, which quite frankly I don't think I can even pronounce, are nearly insoluble in water. Well, remember from the other video, remember from your notes, just remember, water is a polar molecule. And using the adage that like molecules dissolve in other like molecules, well, guess what? These two molecules must be nonpolar, or predominantly nonpolar, because it does not want to dissolve in water. Okay, so there's your answer. That both of these compounds must be nonpolar molecules because water is a polar molecule. So, this is the end of the short answer bonding questions from 2015. Keep working hard.